Today we're going to multiply and divide radicals. Before we start, let's go ahead and review some terminology. To start, here's our radical symbol. Remember, the number that's in that radical, or that little check mark, is called the index. So maybe we'll put a 3 there. So that's an index of 3. And then the number under the radical, say 27, that's our radicand. And then what we look for is what number times itself, this number times, or the number of index times, to get us the radicand. Remember, this cube root of 27 is equal to 3. What we want to do now is go ahead and look at a multiplication of two radicals. And a couple of things you need to remember when we go to multiply and divide radicals. We need to make sure that the index is the same. It must be the same in order to multiply and divide radicals at this point. Later on, we'll look to see when they're not the same and what we can do about that. But at this point, we're going to make sure the indices are the same. So let's go ahead and look at example 1. We're going to take the square root of 8, and we're going to multiply it to the square root of 32. What I like to do, it doesn't have to be done, but I like to reduce each of my radicals before I get started. That makes there smaller numbers to work with. So if I take the square root of 8, we can break down. Since our index is 2, we're looking for perfect squares that go into 8. So we have 4 times 2. 4 being our perfect square. The square root of 4 is going to come out as 2 square root of 2. The square root of 32 is going to be 16 times 2. 16 is our perfect square. That comes out. And we're going to end up with 4 square roots of 2. Now to multiply two radicals that have a common index, we're going to multiply the two outside numbers together, and we're going to multiply the two radicands, or inside numbers, together. So I like to say outside times outside, and inside times inside. So I take my 2 times my 4, gives me 8. Multiply my radicands, or my insides, together, I get 4. And then we're going to simplify it again. The square root of 4 is 2. So we could multiply that square root of 4, which is 2 to the 8, gives us 16. And 16 there is our answer. So what we did first is we simplified our radical, then we multiplied the outsides together, then we multiplied the insides together, and then we simplified one last time. And that's a multiplication. Now we can get more complicated, of course. Let's look at 2 third roots of 9 times the third root of negative 24. Well, here, the third root of 9, that doesn't simplify anymore, so I can't do anything to start. But the third root of negative 24, we can simplify. Negative 8 is a perfect cube times 3. So we're going to bring down our 2 third roots of 9, and we have multiplied to that the third root of negative 8 times 3. The cube root of negative 8 is negative 2. So we have 2 third roots of 9 times negative 2 third roots of 3. Now, since our indices are the same, we can go ahead and multiply the two outside numbers together. So we get negative 4. Our index is going to stay the same. 9 times 3 gives us 27. And we can simplify the square root of the square root of 27 to negative 4 times 3, which is negative 12. And negative 12 will be our final answer. So a couple of things to remember is that the indices have to be the same, and they're going to stay the same after you multiply them together. Now let's go ahead and take a look at example 3. Here, let's take the square root of 7x to the 5th and multiply it to the square root of 42x y to the 9th. Notice here we can go ahead and simplify our radicans, which are the variables. Remember, in order to be a perfect root, in this case it's a square root since there's a 2 that we don't see, this number has to be divisible by that index. So what we're going to do is take that x to the 5th and break it up into x to the 4th times x. Notice we still have x to the 5th if we were to multiply this together. Here, I'm going to break my 42 up into 7 times 6. Now I know neither one of these are perfect squares, but it's going to be useful later on. Here I'm going to multiply my x and my y to the 9th. Y to the 9th, again, is not divisible by that 2, but we can break it down to 8 and 1. So we still have a total of 9 under there. 8 plus 1 gives us a 9. But 8 is divisible by the 2. Now cleaning this up, x to the 4th is going to come out. Remember, we're going to divide the exponent by the index, so we get x squared, square roots of 7x, times, we're going to bring our y to the 8th out, so we get y to the 4th, and then 7 times 6, x, y. Now comes why I broke up the 72, or this 42, into 7 times 6. Well, notice over here we have 7, and I want to make perfect squares in here. If I were to multiply 7 to 42, be a large number, and then we have to come up with a perfect square that goes into it. Here, notice if I multiply this together, I'm going to multiply my outsides together, so I get x squared y to the 4th. And now I can take my 7 times 7, which is 49, or we can think of it as 7 squared times 6, and then x squared y. Notice now our 7 squared, or if you wrote 49, is going to come out as 7, and the square root of x squared is going to come out as x. So the 7 squared comes out as 7, and the x squared came out as an x. So multiplying those to what's out there already, we have 7, x to the 3rd, y to the 4th, square root of 6y. And there's your final answer. Now let's go ahead and look at a little more complicated example to where we're going to multiply 4 radical 3, now maybe to a binomial. So if I take the square root of 75 plus 4. So if I were to multiply this together, I would distribute my 4 radical 3 into my quantity. Before I do that, I probably want to go ahead and clean up the square root of 75. I know that the square root of 75 is 5 square roots of 3. Why do I know that? Well, if I come off to the side, the square root of 75 is 25 times 3. The 25 comes out as 5, and I'm left with radical 3. Now I can go ahead and distribute this, and it makes it a little nicer to work with. Remember, I multiply the outside number to the outside number, inside to inside. So I end up with 20 square roots of 9 plus, well, here I don't have a radical, so I only work with the 4, and it's going to multiply to the 4, which is another outside number. If we think about 4, we can write it as the square root, or 4 square roots of 1. There I'd multiply my 3 to my 1 and still end up with 3. So 4 times 4 gives me 16. 3 times 1 gives me 3. Now I can go ahead and clean this up just a little more. The square root of 9 I know is 3. So I'm going to bring that out and multiply it to the 20 and end up with 60. Remember, if my radican is a perfect square or a perfect root, then I'm going to not have a radical left in my answer. And if I take 16 radical 3, I cannot reduce that at all. So there's my answer, 60 plus 16 radical 3. Now let's go ahead and move on to division. In division, it's not all that complicated at this point either. because we're going to work with some fairly nice numbers. Here, if I take the square root of 500 divided by the square root of 5, well, if I have the radical divided by a radical and my indices are the same, in this case it's 2, I can think of this as the larger radical of 500 divided by 5. We know 500 divided by 5 is 100, and the square root of 100 is 10. So our final answer would be 10. Now in our next example, which would be example 6, I'm going to look at a little more complicated problem. Here I'm going to take the fourth root of 243, x to the 8th, y squared, divided by the fourth root of 3, y to the 6th. Now, again, since my indices are the same, I can write it as one large radical. So I have the fourth root of 243, x to the 8th, y squared, divided by 3, y to the 6th. I can go ahead and divide this out. 243 divided by 3, I get 81. My x's, I only have x to the 8th. And remembering my rules for dividing variables with exponents, I have 6 on the bottom for my y's. I have 2 y's on the top. Subtracting 6 minus 2 gives me 4, but I have that on the bottom. And I still have the fourth root of that entire fraction. Now I'm going to come along and look to see if I have fourth roots. If I look at 81, the fourth root of 81 is 3. The fourth root of x to the 8th is x squared. Remember, we take the exponent and divide it by the index. So 8 divided by 4 gives us 2. Divided by y to the 4th, and the fourth root of that, 4 divided by 4, gives me y to the 1st. And there's my final answer, 3x squared y. And that will take care of our multiplying and dividing of radicals.